So we were talking about the computation of the cost. So here in this problem is relatively simpler than what we did before. It's a constant cost. If the cost is varying with years, okay, we already did a detailed problem on that together, how to decompose the cost and how it's varying for each year. So you have here, because it's constant here, I don't have this problem. So I have 50 plus 75 equals 225 euros per year. Okay, now second step for the salvage value is 450 euros. So here, because I'm calculating the net present value at year end, I should include the salvage term. If I'm calculating that NPV at any other year, I don't include the salvage value. So here I have that CN is, so this represents CN, this is 450. Now, the turbine operates 2,800 hours per year. Why do I need the number of hours of operation? Because I know the selling price per, if you want, per kilowatt hour. So I need to determine what is the number of kilowatt hour produced by my turbine. Okay. Here, for example, they gave us a turbine. Or each problem you can have another system. So depending on the description of the system, you can determine what are the incomes. Okay, let's say a solar collector, for example. If you have a solar collector system and they give you, let's say, also in similar way, let's say in the previous example, okay, they gave us the solar collector energy rate, and we know what is the time that the solar collector will operate during the year, then we can assess what will be the amount of, if you want, energy saved by the solar collector, and this amount will be used to calculate the income. Okay. So next step then is to calculate here, as we said, the income per year. So since we are doing the analysis here, when we do the summation, we consider the cost per year and the income per year. So the income per year, RI here, is equal to the number of kilowatt hour, which is 2,800, times the selling price of €1 per kilo of 1 kilowatt hour. So we know what is the amount of money that we should pay per kilowatt hour. So then here, because if you want, your turbine is able to produce this amount, then this is the money that will be delivered by your turbine system. Because each kilowatt hour, you can sell it with an amount of 0.09 euros. So in total, your income will be per year 2,800 times 0.09. Okay. Now, how to deal with this term? As I told you, I'm not expecting that you will enter this term on the calculator. It's true that you have calculators that can calculate this term, but I consider for the exam that you have a simple calculator that cannot calculate summations. This is why you should know how to apply the geometrical series. Okay, and this this equation will be given for you in the exam. Yes?
Doctor, I have a question. We should first transform the 2,800 per year into per hour before we multiply it by 0.09.
هن عطيوك already. Look, they gave you kilowatt hour. The generated انت عندك number of hours of operation.
Hours. Okay. Sorry.
Okay.
Yes.
Yeah. Okay. So.
السؤال مش لازم نضربها ب 2
لحظة. Yeah, exactly. Yeah, I see what you mean. Yes, of course. Yes, sure. We should just also multiply by the number of kilowatts. Okay. لأنه نحن انا I considered انه هن دغري اعطونا 2800 كيلو وات اور. هن 2800 هو number of hour, but تصير عندنا الكيلو وات hour we should multiply by what? By the power of the turbine, صح? Which is 2 kilowatts. So here we should multiply by 2 لأنه this is not in kilowatt hours, this is the number of hours of operations. So this is the number of hours of operations. Then to get the number of kilowatt hour, we should multiply by the power of the turbine, which is 2. Okay? In case they gave me directly the number of kilowatt hour of the turbine, then I use it directly. Okay? Here because they gave me the time and I know the power, I get the number of kilowatt hour produced. So yes, you should multiply by 2 here. Okay? So again, I repeat, because they gave me the selling price, so the selling price is 0.09 euros per kilowatt hour. Okay? Then to get the income per year, I should determine what is the number of kilowatt hour produced by my turbine system per year and multiply it by the selling price to get my income. Okay? Now, in this problem, they didn't give me directly the number of kilowatt hour produced by my turbine, but they gave me the power of my turbine. The power is in kilowatt. And the number of operation in hours, they gave me the number of hours for which my turbine is operating. So all I have to do is to multiply the power of my turbine by the number of hours to get what is the total. Let us call it big N because we already have small n. Oh, already also we have small n. So you can you can give it the name that you want. Okay, you can NH, number of hours. So if you multiply number of hours by P, you get your total energy per year. Energy E produced in kilowatt hour per year. And since you know what is the selling price of 1 kilowatt hour, by multiplying 0.09 by the number of kilowatt hour produced by your turbine, which is here 2 times 2,800, which is equal to 5,600, then you can determine what is your benefit per year. Okay, so nearly, this is very close to 0.1. You are very close to an income of 500, let's say 550 or 560 euros per year. Okay, so this is the amount you are gaining per year. Now, once I assessed the different terms, as I told you, I still have the summation term. Okay, I still have to compute the summation term. For the summation term, I will use a geometrical expansion. Okay, because again, I repeat, I consider that I don't have a powerful calculator. I have the basic calculator and I want to perform my calculation. So my summation, to compute my summation from I to N, I will use the following formula. Okay, here in this problem, because for all years I have same income and same cost, no need to do any decomposition. So for this formula, it's already straightforward. Sum from I to N. If I take Ri minus Ti outside of the summation, I have then the summation of from 1 to N of 1 over A plus 1 plus A to the power I can be calculated as 1 plus A to the power N minus 1 over A times 1 plus A to the power N. And again, I repeat for you, in case I have variation of cost or income during years, I should decompose the formula as we did in the example, the detailed example we solved together بالvideos. Okay, so now, so please ما حدا ما يستعمل هيدي الفورمولا بالexam. I don't want you to keep it as summation. I want you to decompose it so that you can use any calculator to find the value of, if you want, value of the summation. Okay, so now after you set this equation, you put the condition. What is the condition? The condition is that you want to calculate the CER. So you have everything. You just have to plug in your terms. You have the discount rate. Please pay attention. It's a percentage. ما حدا يحط 3 بالايكويشن. It's not 1 plus 3. It's 1 plus 0.03. So you divide by 100. Okay, it's 3 over 100. You replace in the formula. You get your NPV at year end. And then you divide by the investment to calculate the CER. If you get a CER larger than 0.3, you say my project is profitable. If you get a CER smaller than 0.3, you say I don't advise to invest with this project because the income at the end of lifetime will not give me enough high percentage of benefit. Okay. Any question
Doctor, I
on
have a
this
question.
part?
Yes, doctor.
Yeah.
If you give me, for example, the efficiency of the system,
Yeah.
In order then to calculate the annual revenue, I have to multiply also by the efficiency, right?
Yes, right. Of course. Of course.
Okay.
Okay. Now, calculate the non-discounted payback period. What do you understand by non-discounted payback period?
So basically A equal 0.
Yeah. This means that I don't account for time effect. I consider that the value of money is not changing with time. Okay? Please pay attention. Can I use the formula developed here if A is 0? Look, I cannot use it because here in the geometrical expansion, I have 1 over A. I have 0 in the denominator, so it's indeterminate. So whenever A is 0, I don't need anyway this formula because the computation will be much easier. I can just calculate.
Simply add the components.
Yeah, I can say what are my incomes, what are my revenues. I should to find the number of years to have a payback. Payback period means that NPV is 0. So I just write a new equation without A because I don't have A. Okay, so I don't have to put A. I just have to rewrite my problem without taking into account the time variation. So I consider that my incomes per year will have the same value for all years. And also here, because my costs are not changing, so all I have to say is the following. I will write that. Let us write together the equation. We want to find the non-discounted payback period. So this means that I want to find the NPV for year N. We want to find what is the number of years to get NPV equal to 0. If I don't have variation of value of money with time, so I have minus I, the investment, okay? Now, who will tell me what will be the expression of the balance of income and revenue function of N? What should I add to this investment?
So is it the same as NPV, but considering A is equal to 0, then it's over 1 to
ما
power
في A.
N.
هون ما في A، يعني ما فيك تستعمل هيديك الفورمولا لأنه فيها A بالدenominator. You have A here in the denominator. So you cannot
here
use.
we have.
Yeah, what you can use, you can say here, if I have the revenue and costs are not changing in value with time, yani what is the total benefit I will get for N years? So it's
CI
N
minus I times 30.
It's N times RI. And what are the costs that I will pay? Minus N times
RI operations.
Yes, minus N times C. Of course, I have two costs, the maintenance plus the operational costs. And do I have to add the salvage value here? Do I have to add the salvage value? No.
It's not for year N.
Yeah, of course I will not have to add it. So this is equal to 0. And then I have everything. I have the investment, I have the income, I have the costs. I can compute the value of n.
بس ما بنزيد
So in this
السالفج
way,
نزيدها
way,
برات الان نو
نعم.
بنزيد السالفج برات الان ما هيك يعني بلس سالفج مثل
لا
ماينس انشال
ما بنزيدها لا، لانه
ما
انت
كيف عم
حتكون
بيطلع لنا
بعت
المصاري؟
لك انت اي متى بتبيع السيستم؟ بتبيعه at اليير ان ولا على الفاينل لايف تايم؟ انت after 5 years هتبيع السيستم اذا هو بعيش 30 years شيء؟
لا على 30
على 31
بس ما انت بعد ما
هون
وصلت على
بتصير
30
قبل اوكي
بس يمكن طلعت الآن تبعنا قريبة
اذا
إنه
طلعت
close to
الان
the
اوكي
final.
look اذا طلع اصلا اذا طلعت الان اذا بدكم اكبر من اللايف تايم للسيستم كارثه. يعني ما يعني حيضل نيجاتيف بالانس كل الوقت. اوكي يعني نحن
يعني
when we
هون
calculate نحن when we
assuming إنه
calculate
رح
a
نربح.
payback period we expect انه تكون اصغر من اللايف
Less
تايم.
than the
اذا كانت
lifetime.
اكبر من اللايف تايم يعني اكيد اخر شيء اذا طلعت اكبر لازم نزيد السالفج فاليو بس بنكون خسرانين يعني ما حنربح شيء. اوكي يعني فينا نقول اذا طلع لنا ان اكبر من اللايف تايم بنقول this system is not economically viable because we will have always a negative energy balance whatever is the number of years before the end of lifetime. يعني اصلا اذا طلع لنا ان اكبر من 30 يعني ما في payback period. شو يعني payback period؟ يعني I want to find a number n should be smaller than 30 in a way to have zero balance. إذا طلعت لي n أكبر من 30 يعني I can never have a payback. I will always have a negative balance. Okay?
يعني
أوكي.
كل ما we want to calculate the payback period we take into consideration كأنه نحن we're thinking it is profitable فما بناخد salvage value حتى لو كان
ما
discounted.
بناخذ السالفج فاليو لأنه شو يعني salvage value؟ salvage value هي الاماونت اوف ماني اللي فينا نرجع نسترده بس يخلص اللايف تايم اوف ذا سيستم. يعني انا اذا عندي سيارة اذا عندي هيدي الويند ترباين بعد 30 years ما بتعود تشتغل بس فيني استفيد من البارتس تبعها من القطع تبعها بيعهم. اوكي بس انا اكيد ما راح بيع الترباين قبل ما يخلص وقتها ولا بكون انا الانفستمنت تبعي خسران. لانه انا عاده بس اعمل بروجكت كل ما زاد اللايف تايم تبعه it's for my own benefit لانه انا دافع initial cost كبير فتقدر اعوض هالinitial cost لازم استعمل السيستم على كل اللايف تايم تبعه واستفيد اذا بدكم منه للاخر. يعني اذا بعته قبل بكون انا عم بخسر لانه each year I'm getting an income صح؟ فاذا بعته بكير يعني ما عم بستفيد من الانكم للاخر. This is not ما حدا بيعمل هيك. يعني whenever I put a project I should use it for the whole lifetime. Okay?
Okay.
Okay. So this is how we account for a non-discounted payback period. Now, another question. Calculate the rate of return on investment value. What do we mean by the rate of return on investment?
So it's when NPV equal to 0, but with discount is included. So we need to calculate the discount at NPV equals 0.
Okay, but NPV at which year?
At the end?
Yes, at the
or
end. Yes. Look, ROI value, rate of return on investment. هو الvalue of the discount rate يلي just بيعطيني payback period equal to n. هلا شو الهدف من الكالكوليشن of ROI؟ ليش بعمل calculation ل ROI؟
لأعرف إذا it's profitable حتى أشوف إذا الديسكاونت أقل منها بعرف إنه هذا البروجكت
Exactly. تعرف الرينج of discount rates that I can work with to be on the safe side. Okay? يعني أنا برأيكم ال ROI كل ما كان أكبر كل ما أحسن أو لا؟
اكيد، لانه بصير كل ما كان ديسكاونت اقرب على ROI، وين ما كان نقدر نعمل هالانفستمنت وينجح.
كل ما كان كل ما كان بعيد اذا بدك مش قريب، يعني لانه ال ROI بيعطيني range of discount rates for which my system
Exactly.
will be
يعني اذا كان
profitable.
اعلى
يعني
احسن.
انا مزبوط، يعني تخيلوا ال ROI is 5، يعني انا مجبور يكون discount rate A smaller than 5 to
بين
have
0
a
5.
profit, which is not a good range، يعني كتير limited. بينما إذا طلع ال ROI 20%، يعني for any discount rate below 20 I will gain. Okay? So كل ما كبر
يعني
ال
this means in many
ROI
countries تكون profitable، يعني وين ما كان في degree of stability للcountry.
مظبوط. ما أنت بس يكون stable الكونتري، يعني أنت كتير بعيد عن 20%، which is very good.
Yes.
يعني إذا أنت
يعني
1
profit
أو
أحسن.
2 أو 3%، يعني أنت كتير بعيد عن ال ROI، يعني حتربح كتير، لأنه ال ROI بيعطيك just and PBN equal to 0، فكل ما صغرت عنه كل ما تربح زيادة. فإذا already هو صغير، إذا already ال ROI value is small، يعني أنا عندي limited range بقدر أربح فيها. and even if I am in a very stable country ما حأربح كتير. بينما إذا ال ROI is high I have a large interval of discount rates that I can work with، وكل ما صغر ال A أنا كل ما أستفيد أكتر، صح؟ Because the
Exactly.
smaller the discount rate يعني I am more confident in future, and this
يعني
means
investment
that
أكتر.
I will gain more.
Profit أكتر. Yes.
Okay, so this is the
وليد،
idea. Now
هيك بس تأكد الجيومتريك رح تنعطى بالفحص، هيدي السميشن كيف نحولها على
هيدي رح تنعطى. Yes, this one, but you should know how to apply it. Okay.
Yes.
Exactly. You should know how to apply. So
Professor,
now, نعم.
can you repeat the concept of A greater than ROI and like why it's better?
Okay, yes, I will. Okay. Look, ال ROI هو discount rate for which net present value at year end is just equal to 0. انتوا إذا أنا بعطيكم project ال NPV at year end is 0 بتقولوا لي it's a good project شيء؟ يعني شو يعني NPVN is 0؟ يعني أنا للend of lifetime للend of lifetime of the system تبلش أربح، يعني ما راح أربح شيء at the end لأنه خلص ال lifetime of the system. This is bad. Okay. بس ليش we calculate ال ROI؟ لأنه نحن بنقول إنه نحن ما بدنا يكون ال NPVN 0، بدنا إياه يكون positive، وحتى ما بيكفي يكون positive إذا ما نستعمل ال CAR criterion مفروض إنه ال NPVN يكون 30% higher 30% minimum of the investment. أوكي؟ يعني أنا ما لازم أشتغل بديسكاونت ريت قريب على ROI. I should have a smaller, much smaller كمان than the ROI. Why؟ لأنه كل ما أنا A بيصغر يعني I am more confident in the country I am investing in، يعني I will benefit more. فأنا من مصلحتي أشتغل بديسكاونت rate smaller than the ROI. فأنا when I calculate the ROI بصير أعرف شو هي الرينج of discount rates I can work with. يعني إذا طلع لي ال ROI 4% بقول in any country that is not stable هالبروجكت ما حيقلع أبدا، وحتى بالdeveloped countries ما حيربحني كتير، لأنه أنا ما عندي كتير إذا بدكم interval to play with، فيني بس لازم يكون أقل من 4%. يعني حتى إذا كنت 2% which is very confident a high confidence rate هضل إنه قريب على ROI ما حأربح كتير، لأنه for 4% the NPVN is 0، يعني for 2% قد حأربح I can calculate it ما حيكون a very large amount. On the other hand, if ROI is big, let's say I have ROI 20%, for example. This is very good. لأنه ساعتها for a discount rate smaller than 20, I will have NPVN positive. So إذا بشتغل ب 1% أو 2% أو حتى a 5% discount rate, I am still very far from ROI, and I am on the safe side. I will have NPVN much larger than 0.
But Professor, one question. نحن when we're calculating the ROI, we're calculating A. So what do we mean when we say it's less than A is less than ROI?
الكالكوليتر بتعطيك هلا انا اذا انا طلبت منك to calculate ال ROI اوكي انت لازم تعمل iterative procedure. I don't want you to plug the formula in the calculator as it is والcalculator تعطيك ال value because I don't expect that you use بالcalculator summation. I expect that you use geometrical expansion. يعني أنا كيف بلاقي ال ROI؟ أنا بكتب ال equation. What is the unknown in this? هلا أنا حقلكم إذا بدي إياكم to solve or not. يمكن لكم just write the equation without calculation. Okay? إذا قلت لكم calculate you should use iterative procedure مثل الإكزامبل اللي عملناهم بالفيديوز. نرسم table بنحط مثلا إذا payback period بنحط for n equal 5 what is the NPV for year 6 what is the NPV for year 7 لحديت ما اقدر القط اذا بدكم البوينت. يعني انا for the payback period اذا for year 6 I have a negative NPV and for year 7 I have a positive NPV, this means that the payback period is 7. You should do iterative procedure. Okay, you are not expected to directly give the result from your calculator. You should construct a table and say what is the method to use and give if you want tool analysis. يعني أنا بال ROI the only unknown will be A لأنه number of years هو ال end of lifetime. So N is known to be here and PV at 30. My only unknown here will be the value of ROI اللي هي discount rate at year N. Okay, اللي just بيعطيني NPV equal to 0. So A هي ال ROI تبعها هي unknown. So I should do assumption. إذا بدي أعمل iterative procedure, I should assume. I should say أنا حكون عملت ال geometrical expansion. Okay, and I say let me assume the ROI مثلا is 10%. هلا أنا ببلش ب with experience you will know how to start. يعني فينا أبلش مثلا ب 10%. ب A equal 10%. إذا طلع لي ال NPV positive, okay, يعني شو لازم جرب value أكبر أو أصغر لل ROI؟ أكبر. اوكي إذا جربت 10% وضلت positive يعني يعني ال ROI بعد أكبر من 10. So I can try let's say أول شيء فيني أجرب 20. ساعتها إذا طلعت على 20 negative يعني I am sure إنه ال ROI is between 10 and 20. يعني 3 iterations بتزبط معكم. ما إنه مش حتعملوا 10 iterations أكيد لا. بس just some trials you will know the value. Once you try 10 and 20 بتقولوا حجرب 15 مثلا. أو حتى sometimes فيكم تعرفوا إذا هو أقرب ل 10 أو 20. يعني مثلا إذا for 10% طلع لكم ال NPV plus example يعني plus 20 وعلى ال 20% طلع minus 100 يعني I am closer to 10 than 20. يعني فيكم ترجعوا تجربوا بدل 15 12 for example. إذا for 12 طلعت negative يعني خلص صرت كتير قريب. I say it's between let's say 10 and 12. I use 11. على 11% طلعت nearly zero. خلص I say the ROI is 11%. Okay.
Professor, at what range do you want us to stop? You know, plus 50, plus 20, plus 100?
Yes, you will use just يعني بس sorry can you repeat لأنه آخر شيء ما سمعت مظبوط.
Okay, I was just asking, you know, when do you want us to stop? يعني the difference between 0 and the value
لا
that
okay yeah it's fine. ليك إذا أنت مثلا عملتها بين 10 و 12 وطلعت وجربت 11 وطلعت يعني let's say 1 okay 1 أنت شوفها compared to the investment. يعني إذا ال investment here قلنا إنه هو 2 times هو 3000 خلص يعني 1 إذا طلع لك 1 إنه it's nearly zero. يعني compared to 3000 حتى you can يعني 1 يعني حتى إذا طلع لك 3 4 5 it's fine يعني لأنه it's nearly 1 over 1000 of I. So مش ضروري انت ما حتوصل لزيرو exactly. ما حتوصل 0 100%. خلص بتقول ROI is nearly nearly 100%. Okay.
ايه exactly، بس قصدي اذا بيطلع لنا 20 30 40 لانه اوقات تنسيق between 30 40 و 3 بضل فينا نجرب، لازم نجرب يعني مع البرسنتج بيصير كتير differences صغار، يعني مع 8.1 8.2 8.3. فاذا بيطلع لنا
لا
مثلا
لا
شي
لا مش ما بدي هالقد details. No, it's fine. خلص يعني just you confine it to a closed interval and you stop. اوكي. وحتى
اوكي
30
اوكي
40 ما حتكون هالقد، يعني ولا مره الار او اي بيكون هالقد 30 40.
لا مش قصدي ROI، قصدي الفاليو تبع NPV.
الفاليو تبع الان بي في، الفاليو تبع الان بي في should be close to zero. اوكي. قلت لك تتعرف اذا it's enough تطلع، يعني انت اذا طلع لك الان بي في هي لازم تكون زيرو. اذا طلع لك 3 4 5 وانت الانفستمنت 3000 خلص you're considered nearly zero. يعني it's nothing compared to 3000 3 4 and 5. هلا اكيد
اوكي
30 لا 30 بعدها كبيره لانه تقريبا يعني 30 صرت بال1%. اوكي بس صرت كثير قريب. يعني اذا بتجرب بعد، يعني اذا صرت بين 10 و11 وطلع لك 30 يعني فيك تاخذ مثلا 10.5 ساعتها اكيد حتصغر كثير، يعني حتصير بالرينج 3 4 5 and you can stop.
اوكي
اوكي. ما حنوصل
إيه.
للزيرو 100%. انا ما بدي، مش هدفي تجيبها 100%. مهم تعرف تعمل الاناليسيز وتعرف تكمل الiterative procedure to be very close. Okay.
Okay, thank you.
Any question on the economical analysis? Any questions? Okay. So this is for the economical analysis problem. Let us do a problem on wind turbines. Consider a wind turbine of cross-sectional area of 12 meters square. Wind crosses this area with a velocity of 50 kilometers per hour. Knowing that the upstream velocity is equal to 70 kilometers per hour, the gearbox efficiency is 90% and the generator efficiency is 80%. Calculate the power extracted by the wind turbine, its coefficient of performance, and the electrical power produced. Okay, so here, if you remember in the chapter of wind energy, we developed together the technique to know what is the power extracted by a turbine. And we started by applying the momentum equation for the control volume of the turbine. Okay, I consider إذا بدكم إنه this part because it was covered in the course material you should know how to do it. بس هي أكيد ما حجيب لكم أنا system جديد وأطلب منكم momentum because it's little bit complex. But because this was derived in the videos and explained in detail, you should know how to get it. But just for this example, يعني I will not give you fluids بالexam أكيد. Okay, so here if you go back to the course material, we derived together what is the force developed within the turbine using the momentum equation concept. And we know that the power is force times velocity. So we have a formula giving us the power that can be, if you want the maximum power, that can be the value of the power that can be extracted from our turbine. بس كمان إذا بتتذكروا نحن قلنا إنه we cannot extract the whole power. We cannot take 100% of this power. We have a limit, and this is called the Belt's limit of the system. Okay, and we derived in the course material why we have this limit. So here, the first question is to get the power extracted by the wind turbine and to compare it to the maximum power we can extract. Okay, so from the momentum analysis, we can get the expression of the power. So this is the power that we extract actually, but we know that this power is not, if you want the maximum we can get, because we have a certain coefficient of performance that will limit the percentage of power that can be used. Okay, so this is if you want the extracted power, and if we want to know what is the coefficient of performance, we should divide it by the maximum power that can be extracted. And the maximum power that can be extracted, we know its expression also. Okay, so we have developed already also in the course material that the maximum extracted power from a wind turbine is the following. It's half rho U0 cubed times A1, where U0 represents the upstream velocity. Okay, so if I am able to extract the whole energy, the whole power present in the fluid, the whole power present in the fluid is half rho U0 cube A1. Okay, but in reality, as we developed in the course material, I cannot extract this full amount. What I can extract is, because of momentum relation, is rho U1 squared times A1 times U0 minus U2. In this problem, they gave you everything needed to calculate your unknowns, because they told you, if you go back to the given, they gave you first what is the cross-sectional area of the wind turbine. This represents A1. Okay, this represents A1. And also they gave you the velocity crossing the wind turbine. The velocity crossing the wind turbine is U1, because we associated U1 with A1. In addition, they gave you the upstream velocity of wind. So this is the velocity of wind very far from the wind turbine. So this is A0. This is A0. In the course material, we have seen that the extracted power expression is given by the following formula. Function of U0 and U1, which is 2 rho U1 square A1 times U0 minus U1. We have all parameters here, so we can calculate this power.
نحفظها الفورمولا.
Look, هيدي الفورمولا هلا أنا لأنه because I explained all details, you should know the steps. But as I told you, only for يعني ما بجيب لكم أكيد case تاني, because you need fluids, and I know that مش كلكم عندكم deep knowledge بالfluids. But here, because we derived it together in class, يعني you are responsible of it for this specific case. And you should know how to get it. But I don't expect إذا بعطيكم شيء تاني to use it. So if I give you something, another system, I will give you the formulas. Okay, but just for this system, because it was explained in detail, you should know how to get it. Okay?
Okay.
So first, we can calculate the power extracted for the wind turbine from the inputs, and it's a numerical replacement here to get the power. Now, what is the coefficient of performance? If you remember, when we talked about CP, we said that the coefficient of performance is, if you want, it's like an efficiency. It's what is the